All right, in this screencast, we're going to investigate Gay-Lussac's law, which is pretty important. It investigates why and when you should inflate your tire pressure. It's dealing with the pressure and temperature aspect of gases. All right, so as you can see in this graphic, it lists cold tire pressures. And if you think about it, if you inflate your tires to these particular pressures when they're cold, they would be a totally different pressure when the vehicle has warm tires, as in having driven around for a long time. So you wouldn't want to inflate your tires to these numbers if they were warm, because when the tires cooled down, then you would be way underinflated. All right, so tire pressure is very important. And you can also see here in this graphic, if you have a balloon at room temperature and you go outside in the heat, the pressure increases as the temperature goes up. And if you put it in air conditioning, it would then shrink down. So you probably see this if you've ever left a ball out in your yard and it's now suddenly winter and you're like, wow, it shrunk. Or maybe it's leaked, and what has happened is that it's just reduced in size. So the variables we're going to be looking at are pressure and temperature, and we just looked at them here. You can see that as the temperature goes up, so does the pressure, and vice versa. As the temperature goes down, the pressure goes down. So in this law, like I said, we have the pressure, and pressure increases, temperature increases. This is a direct relationship. And remember that the amount of gas, so moles, and the volume are constant, so these are not changing. The equation that we're going to be dealing with is P1 over T1 equals P2 over T2. And again, the pressures can be anything. Any of the STP values are okay, but you have to have your temperatures in Kelvin. And so recall that Kelvin is equal to the Celsius plus 273.15. It's important. You will get the answers wrong each time unless you've converted them to Kelvin. All right, so here's a sample problem. A soccer ball has a pressure of 0.95 atm in the morning at 20 degrees Celsius, so chillier. Later in the day, when the temperature has increased to 27 degrees Celsius, what's the new pressure? So our information given is we have an initial pressure of 0.95 atm, and we have a temperature initially of 20 degrees Celsius, but remember we have to convert that to Kelvin, so this is going to become 293 Kelvin. And we have, we are looking for the new pressure, so we don't know that. And they give us a second pressure. And they give us a second temperature of 27 Celsius. So again, we add 273 to that, and we get 300 Kelvin. So if we set this up, we take 0.95 over our 293 equals P2 over 300. Again, you are going to be cross multiplying. So you're going to take the 0.95 times the 300, and that will be equal to the 293 times P2. So you will multiply these two and divide by this one. So your P2 ends up being 0.97 atm. And that makes sense. If you look at it, our temperatures are increasing, so our pressures should increase from 0.95 to 0.97. All right, so it's homework time. I need you to solve this problem. Submit your answer and your work in Schoology. Remember, this is Gay-Lussac's law. So you will need to find that particular assignment in Schoology, and you are going to solve the problem. It says a balloon bouquet is inflated at the mall in the summer at a cool 22 degrees. Oops, we forgot a unit, so that's 22 degrees Celsius, and a pressure of 0.99 atm. The balloons travel in a hot car at 37 degrees Celsius, and what is the new pressure? Okay, so you are solving for P2 in this problem. Make sure that you show your work, set it up, solve it, and submit it in Schoology to the assignment for Gay-Lussac.